Sequence and series, what's the difference? That's it. Everybody get that? Okay, so we've done arithmetic series. Sum is the word. Add them all up. One word, sum. Okay? Same thing. Now we got a sum of a geometric series. Here's maybe one of the most basic ones. Okay, if I go to, I don't even know if this is a number in that series, but what's the sum? What's the total? I'm given the last one, the nth term. I have the first term. I know what r is. What's the sum? Okay? So I'm not gonna, there's no cool story here of some 10-year-old who came up with a formula. I'm just gonna throw them out there. Okay? So here's, well, I guess it's pretty straightforward. On your formula page, like I say, we're going to get a test. It's going to be all sequences and all series. You got to make sense of the difference between arithmetic and geometric. How do you know that one? When you look at, you just look at SN. It doesn't say geometric here. How do you know that's geometric? Yeah, because there's no R in arithmetic. It's going to be a D, isn't it? Okay? Okay? So that's one form. Is this any different than that one? No. No. I think most of us, from what I've gathered, like A, but that's the same as T1. Okay, so we don't need to look there. And for less confusion, on your formula sheet in your book, cross that one out if you think you're never going to need it, never going to look at it, right? Why have more there than what you need? It's just going to confuse you. This one, though, is a bit different. Why is it a bit different? Okay, well, we know t to the n is a r n minus 1. That's what we used for sequences. They took this and substituted it in either one of these formulas and came up with either this one or this one. We don't need to know how this happened. Okay, I'm not going to show how this can be developed from that one. We just need to know which formula we're going to use. Okay, so what's the difference between this one and this one? As far as variables go, does this one have an A? It has an A, yeah. So does this one. Okay. Here it is. Okay. Does it have an R? Let's try this, Reese. Does it have an R? Okay, good. So does this one. Okay, the difference is that one's got an N. This one has a T to the N. All right, so they substituted this formula in here and came out with this formula. We don't have to derive it, okay? We just need to know the difference. Which one are you going to use? Well, it depends what you're given, okay? My example here, I'm given the nth term. I don't know what n is, okay? So I would want to be using that guy, not this guy. Okay? So we got a couple formulas, a couple of examples. Like I said, should be pretty straightforward. We're getting kind of the hang of this stuff. Most of us are getting some pretty good marks on our quizzes. Okay? Determine the sum of the first 15 terms of this sequence. What are we given here right off the bat? I want to know the sum. Let's write both of our formulas down here. I have this, and we need to be really, really, really careful because I see over and over again people who are writing these formulas out were making mistakes as to, I'll just finish writing that one out. There's our two formulas. Actually, I should take my own advice and write it a little more neatly. I've seen this, okay? So don't do this. And don't write this either, because we need the space. A r to the n minus 1 over r minus 1. Is that the same thing? Absolutely not. Okay? This is not an exponent in r. This is r to the n minus 1. Okay? We see the difference? Don't do that. Okay, what do I got? What's this mean? I got 15 terms. What's a variable for that? Is that a, r, n, t to the n? That's definitely n, okay? So I know n is 15. What else do I know? Well, there's a. Don't know r yet. Can I figure it out pretty quickly? Either one what? Formulas, yeah. Okay, how do I get from -5 to 10? Or, let's not hurt our brains. Let's just take that, divide it by that. Looks like r is -2. Okay? Which formula do I want to use? Do I want to use this one? Probably not. Because I don't have t to the n, do I? Do I have everything in this formula? Yes, that's A, I have it. R, I got it. N, I got it. That's the one I want to use. Okay? So, the sum of these n terms is substitute. And don't be lazy. Just write it out as it is. Just make substitutions. Keep the brackets there. Nice and neat. And nobody gets hurt. Okay? -2 to the power of n minus 1 bracket all over r minus 1. Do we see how easy it'll be to make a mistake there? Okay. What happens if I didn't put these brackets around the -2? In this case, it doesn't matter because this is odd. But if that was a 16, let's pretend, you see how one's right and one's wrong? A negative, an even number of times, is always going to be positive. If I don't put brackets there, BEDMAS says I do the exponent first. 1 to the 8 is 1. Then I do multiplication, division, no, addition, then subtraction last, which is -1. Okay? These brackets are important. Okay? -2 to the power of 15 minus 1 times 5. That's how I'm going to want to put that in my calculator. Okay? Bracket, -2, bracket, to the power of 15 is that. Minus 1 is that. Times -5 is that. Divided by -3, okay? Is that. Yes?
When we use numbers, with the number on the bottom and the number on the outside, we divide them.
Yep.
Do we do that?
You could. Okay, first, that's the answer, then I'll visit your question, okay? So, the sum is, what did I have? Negative, that's a big sum, right? 5, 4, 6, oh, my memory's terrible today. 1, 5. Okay. Don't write down here, we're going to do the next question, but how can I simplify that a bit? I got to do this part first, right? BEDMAS, I have to go -2 to the 15. I can't subtract this from anything, but I could clean up the bottom. -2 to the 15 minus 1. -2, -1 is -3. But how many times does 3 go into 5? Is it even worth doing? Yeah. Okay, that doesn't really help me. Sure, if that was a 6, okay, I would just go negative, negative, that goes in there +2 times. Sure, you could do that. Okay? You'd still have to go negative 2 to the 15 on your calculator, minus 1 times 2. All right? So, yeah, you can, if you want to do that, that's fine, but this doesn't really help me in this case. Okay? Yeah. Because I can't, like, that's fine. I can divide this by this. But remember, that negative 5 applies to everything in the brackets. Alternatively, you could go negative 5 times negative 2 to the 15. Negative 5 times negative 1 plus 5. But I think the way I did it on my calculator is probably the most straightforward way. Okay? All right? Okay. Sum. You're going to get this question on your test. You need to know it's geometric. Easy today because, hey, that's the name of the chapter, not the chapter, the lesson today. It's all geometric series. Okay? So the first thing you need to do is that arithmetic or geometric? Because if you guess wrong, you're going to use the wrong formula and you will not get the right answer, right? So, from 4 to negative 12 is what? I could add by negative 16. Does that work? No, it doesn't. Okay? Must be geometric. What is negative 12 over 4? Negative 3. Is negative 12 times negative 3 positive 36? Yes. Okay? And because this is a sum here, they don't have the commas. Some of you are going, hey, that looks a little different. Yeah, it does. Okay? If you like commas, well, there's one, there's one, there's one. Okay? They just didn't put it in this question. All right? So what is that? That's R. Do I know A? Yeah, it's 4. What else do I know? Number of terms? What's this guy called? The last term, also known as the nth term. That's the last term. That's t to the, I just don't know what n is. Is it 42? Is it the 67th term? Is it the 19th term? I don't know. Okay? So, guess which formula we're going to use this time? Yeah, because we have t to the n. S of n is r is negative 3 times negative, that's Tn. Okay. You want to bracket that one? Sure, that's fine too. Doesn't really matter there. Okay. That's r times Tn minus a all over 4 minus 1. Okay? Okay, Lewis? Could you do this in one step on your calculator? Yeah, you should be able to. But, you know, be careful. Negative 3 times negative 8748. Come on. Minus 4. Yes? Yes. Because that's not a minus 1, that's r minus 1. My mistake. Thank you for catching it. R minus 1 on the bottom, I did a boo-boo, is the technical math term. Okay? So, there's the top. I would press equals. Okay? Divided by, what's the bottom? Minus 4. Okay, is negative 6,560. So we got to be pretty good on our calculators, right? Okay? If we are, we don't have to write this all out, but if you're not, then, it doesn't hurt to write a couple of lines. Make sure you get it right. Be careful. Okay? So that's an example of each formula. Guess what we're going to do now? This wording looks a little different. Okay, the sum of this series is, what are they giving us? They're telling us what the sum is. We got to solve for something else in our formula. What is the last term? What's our variable for the last term? The nth term. That's what we're solving for. Okay, so this one's a wee bit different. That would make this series add to, okay, they're just saying the same thing twice. They're saying the sum is that. Which formula do I want to use? Well, obviously the one with that in it. Okay? Guys, I don't have these things memorized. I look them up. Over r minus 1, not a minus 1. Okay? I got some questions from some kids in chemistry at the beginning of the year about rearranging formulas. Do you want to rearrange that first, or do you want to put the substitutions in first? I think most people would put in the numbers first. Okay, S of n is negative 104,858 equals, what's r? Looks like it's negative 4. A is negative 2. So negative 4 times Tn, that's what I'm trying to find, minus 2 is plus 2, but let's write it all out, all over negative 4, negative 1. Okay? Everybody okay so far? All I did was put in the substitutions. And remember, it's nice to use brackets, okay, when you put in your substitution. So let's simplify this. That's negative 104,858 is negative 4 Tn. Can't do anything with that. Negative 2 is plus 2 over minus 4 minus 1 is minus 5. Okay? Now some algebra. I got to solve this thing for t to the n. I got to get rid of negative 4. I got to get rid of plus 2. I got to get rid of negative 5. What do I want to do first? Good idea. Let's get rid of this. How do I get rid of negative 5? By multiplying it to both sides. Because negative 5 divided by negative 5, it's gone. Okay? So I know this, a negative times a negative is a positive. I'm not even going to put the sign in my calculator. Okay? What is 5 times 104,858? 524,290 is minus 4Tn plus 2. What's my next step? Let's get rid of the 2. Subtract it to both sides. Minus 2 there, minus 2 there. Okay, so I should be able to do this without my calculator. Take 2 away is minus 4t to the n. Last step, get rid of the negative 4. Divide it away. So t to the n is that, subtract 2, divide by, I know the answer is negative, so I'm just going to put a 4 in there. Okay, 131,072, it's negative, that's t to the n. Okay. Is that the last term? Is that the nth term? Is that the value of the last term? Okay. I want to repeat this because some of us still get confused with n and t to the n. Okay? Yeah. Do I care how many terms are in this series or sequence? I don't. It doesn't ask me to find it. Don't need it. I know that's the last term. Okay? Okay. In a geometric sequence, the fifth term, that's T5, is 1024. And the common ratio, that's R, is 4. Find the sum of the first 7 terms. What is that 7? That's n, right? I want to find S7. Is A, I'll just write out both formulas. It's that, okay, or it's that. I have N, I have R, but what do I need here? I need A. Let's look at the other formula. What do I need here? A. Yep, I'm screwed. I got to find A first. That's okay. We know how to do this, right? Because I know t to the n is A r n minus 1. So I know t to the 5 is A, r is 4, n is 5. Okay? This is what we did last day, right? Solve for A. So how do I get A by itself? Get rid of, that's 4 to the 4th power. So divide it away. So what is 1024? This is t to the 5 is 1024. Yeah, right? Okay, so I need to find A. I'm finding A. I can't use this because I don't have A. I can't use this because I don't have I. Find A. I need A. I need A to get any sum. There's an A in both formula, right? Okay, so we're okay? All right, we're good? Okay, so how do I get A? Divide by 4 to the 4th power. You don't have to evaluate 4 to the 4th power and write it down, then divide it by it. Why don't we just plug it in like that? A is 4.
How do you type in a variable over 3 on these ones?
Variable over 3?
I pass the cube.
Okay, ask me after, okay? All right, so we're good with that. A is 4. Okay, so it's a 2-step equation, right? I need to do something before I can use this formula. Which one do I want to use here? I got A. Do I want to use this one? Or do I want to use that one? Well, look at what you got. I have R. I have A. N7. Do I have t to the n? I guess I'm using that one. So the sum of the first 7 terms is A times R to the n minus 1 over R minus 1. Okay, this one looks a little nicer than the first one because there's no negatives for R. Okay. We should put this in our calculator, okay? 4 times 4 to the 7th power minus 1. Okay, that's the stuff on the top. Divide that by 3. 21844. Okay, any questions? Last one. Okay, we're not, guys, one more, okay? Going to use a graphing calculator to calculate this. The sum of n terms, obviously I don't know what n is. Okay, what do I know? I know the first term is 5. How do I get from 5 to 15? Multiply it by 3. And what is this? Read it carefully. Is that t to the n or is that the sum? This sum is, okay, that's the sum. Okay, it looks like, if you look really quickly, that looks like a sequence, and that's the last term there. But there's a word here, okay? This sum is 16,400, so that's a little tricky. Okay? What am I trying to find? Which is the formula that has an n in it? This guy. Okay? So if I need to solve this for n, I better know everything else. Do I know the sum? Yes. Do I know a? Yes. Do I know r? Check. Okay? Got everything else. I should be able to solve that. Okay, so the sum, 16,400, is a times 3 to the n. Now don't make the minus 1 an exponent. I see that time and time again. Over r minus 1. Okay, solve this guy for n. Do we know how to do logarithms? Okay, looks like one of these guess and check ones, right? Okay, but first, get rid of this. This is 2. So multiply both sides by 2, and 2 divided by 2, it's gone. So 32,800 is 5 to the 3n minus 1. What's our next step? You could, but it might be easier if we don't. Can I just get rid of that 5? How? Done? Yeah. Let's get rid of it. 5 divided by 5 is gone. How many times does 5 go into 32,800? Hey, that looks familiar. I think we've seen this number already. Is 3 to the n minus 1. I got to get rid of minus 1. How do I do that? Add it. Add 1 to both sides. Let's go over here. So 6561 is 3 to what power? Guess and check. Okay. How about 7? Close. How about 8? Hey, look at that. 6, 5, 6, 1 is 3 to the 8. Now don't get confused, there's no n minus 1 here. That's what n is, right? Alrighty? Whoop. 1 and 2, A, B, C, 4 to 6, 8, just 10A, because I think B is a graphing calculator. Well, hey, if you want to try it, go ahead. And 11.